This video is for the calculations for a copper hydroxide synthesis lab. And we'll just make this happen pretty easily for us today. So we started off by measuring the mass of a beaker and zeroing that out. So we really don't need that there at all. And we were supposed to add 2 grams of copper sulfate. So I'm assuming that we did that. So I'll make 2 grams there. We would measure the mass of a filter paper that we're going to be using in this lab, and it's about 0.90 grams, so that's what I'll record. After we react this, stir it around and filter it, let it dry overnight. Let's say I get 1.42 grams as my final mass of the filter paper after everything dries overnight. So we need to look at the balancing reaction for this. We also need to look at what kind of reaction it is and do our calculations. Well, first of all, our reaction is between copper sulfate, CuSO4, and sodium hydroxide. So in the form of compound plus compound, and our job is to predict what our reactants become for our products. Well, compound plus compound means we have a double displacement reaction. So that means sodium is going to go with the sulfate and copper is going to go with the hydroxide. And that's what we're trying to make. So we have copper hydroxide. Copper in this case is a +2. Hydroxide's -1. So then we're going to crisscross our charges and get a 2 down here. Plus sodium sulfate. Sodium is a +1 charge. Sulfate is a -2 charge. So we need to crisscross charges. We'll end up with a 2 down here. So these are the products correctly predicted. Now we just need to balance the chemical equation. So we have 2 hydroxides and 2 sodiums. We just need to place a 2 right here. So the kind of reaction, of course, is double displacement. Now we have some other questions for calculations. How many moles of copper 2 sulfate were reacted? Well, the word mole is in the question, so definitely going to be a one-stepper. But we need to understand our form of copper sulfate. Copper sulfate is CuSO4, but it has 5 waters attached to it, 5 H2O. So we would need to get the molar mass of 1 copper, 1 sulfur, 4 oxygens, and 5 waters. The molar mass of that added all up is 249.682 grams. I'll let you add that all up. But I'm going to only call copper sulfate CuSO4. The waters are along for the ride. So when I do my mole conversion, I'm going to say I've got 2 grams of just regular CuSO4, just for simplicity's sake, so it does not get too confusing. So I'm going to times that by 1 mole of copper sulfate over that entire molar mass, including the water, which is 249.682 grams. And that, of course, is of copper sulfate. And that equals 0.00801 moles of copper sulfate. Now we look at the balanced equation, and there's 1 amount of every copper sulfate for every 1 amount of copper hydroxide that's produced. So this one says, determine how many moles of copper hydroxide should be produced. Copper hydroxide should be produced using this chemical equation. Well, if I have 0.00801 moles of copper sulfate and we're supposed to get 1 of this, then that means I should be getting 0.00801 moles of copper hydroxide produced. Okay. Now the next question here is saying, how many grams of copper hydroxide should be produced from this reaction. Well, I know it's moles. I just need its molar mass to convert that into grams. So copper hydroxide, I would need to add 1 copper, 2 oxygens, and 2 hydrogens together. And the molar mass of that equals 97.546 grams. That's what it equals. Okay, now if I want to convert my moles into grams, then I'm just going to be multiplying my moles times this molar mass. Okay, so I'm going to do that up here so that it stays clear, and I'll do that in blue. So I know I have 0.00801 moles of copper hydroxide that's supposed to be produced. I'm just going to multiply that by 97.546 grams of copper hydroxide per 1 mole of copper hydroxide. And the answer to that is 0.781 grams of our copper hydroxide should be produced in this reaction. We're going to call that a theoretical yield. So in theory, if I had 2 grams of copper sulfate, how much of copper hydroxide should I get when I'm done with my chemical reaction? That doesn't mean that we're going to get exactly that much, because there's going to be some experimental errors. Okay. Now let's finish up this part, this video, with getting our theoretical yield. Now I'm going to subtract my final paper mass from the filter paper from my beginning of that. So I'm going to take 1.42. I'm going to subtract 0.90 from that. And I'm getting 0.52 grams of copper hydroxide that I produced in my experiment. Now I'm going to determine the percent yield from that. Well, I've got 0.52. I'm supposed to get 0.781, so I'm going to divide those two, and I'm going to multiply that by 100. Okay. And that's going to be 66.5%. Now, if you get a little confused about this, it's just like a test. What if I got 52 out of 78 or whatever? I would just take the number I got right out of the total and times it by 100. And that's exactly what we're doing. How many grams did I get divided by how many grams I'm supposed to get times by 100. Now, any reasons that there could be errors that doesn't match? I mean, think about places you might have lost some product on funnels and flasks and maybe on the sideboards. Okay, you could have lost some on filter paper that fell off. You know, any kind of reasons for that you could come up with for why you don't have 100%. All right, next video, we'll finish up the lab.